Hello and welcome everyone to the next video lecture of Physics Sadhana. In this video lecture series, we will be discussing about all the PYQs analysis based questions, ECET PYQs explanation in detail, and based on the analysis of the ECET PYQs, we are going to be seeing some most expected questions for the ECET 2025. Important questions at the end of the video lecture. This is the ideal gases part 2 video. Already ideal gases part 1 has been updated yesterday. Now we will be discussing about the continuation of that very topic. Okay, let's move on to the question number 1, which appeared in the year 2021. An ideal gas, again it is a repeated question, we discussed about this question. An ideal gas has volume V, pressure P, mass of each molecule is m, density of the gases. We know the formula for density. Density is equals to mass divided by volume. Usual meaning of density is closeness with which the molecules are bounded. Okay. Mass of each molecule is m, so total mass will be m into number of molecules. Number of molecules divided by volume. We know the formula for number of moles. Number of moles is equals to number of molecules divided by Avogadro's number. So in the place of number of molecules, we can write the formula number of moles. N is small, n is number of moles, small n, and this capital N is Avogadro's number. So what we can write the formula for number of molecules? We can write the number of molecules formula as, write this here, number of molecules is equals to number of moles into Avogadro's number, n into capital N. So in the place of number of molecules, what we can write now? Small n into capital N divided by volume V. Next thing that we need to know is about ideal gas. Ideal gas equation is PV is equals to N into RU into T. We require here N by V. Focus on this one, N by V. Here we have N, here we have V. So N by V is equals to P by RUT. So in the place of N by V, we can write P by RUT. Now to solve the further, we need to know the third formula, that is Boltzmann constant, that is K. Boltzmann constant K is universal gas constant divided by Avogadro's number, RU by N. So now we have here RU, this is the N now which is coming in the denominator, this is the N. So what it will become now? MP divided by universal gas constant by Avogadro number times temperature. And we know that universal gas constant by Avogadro's number is called as K, Boltzmann constant. So this is our final answer now. That is density is equals to mass of each molecule, pressure divided by Boltzmann constant times temperature, MP by KT or PM by KT. This is the final answer. This is a very good question, that's why we did it twice. Because with this we know the formula for number of moles, molecule by Avogadro number, ideal gas equation PV equal to nRUT, Boltzmann constant, universal gas constant by Avogadro's number, and density formula again mass by volume. Okay, go through it. Appear question in the ECET 2021. Moving on to the next question. The volume of 1 mole of an ideal gas at standard temperature pressure is, the pressure is atmospheric 101325 Pascal, Newton per meter square. The temperature is usually taken as standard temperature, it is around 15 degrees Celsius. Some textbook give this value as 0 degrees Celsius too. Okay, 0 degrees Celsius. Normal temperature page, standard temperature page, two temperatures are there, one is 0, one is 15. Finally, that we require volume. Volume is 22.4 liters. It can be written as 22.4 into 10 to the power of minus 3 meter cube. So this is the volume at standard temperature and pressure. 22 into 10 power minus 3. Okay. So this should be exactly, this is 22.4 into 10 to the power of minus 3 meter cube. It's not 24.2, this is 22.4. So this is going to become your correct answer. Go through it. Whereas if you see the, okay, just a minute, because here 10 power minus 2 is there, 10 power minus 2, because if I want to write here 22, this is 22 into 10 to the power of 22.4, no? 22.4 into 10 power minus 3. If I take one digit here, that is I need to multiply here 10. Yes, so this is going to become 2.24 into 10 power minus 2 meter cube. Okay. So I thought it is misprinted, but no. Here 10 power minus 2 is given. So which one is the correct answer now? Option number 1 is the correct answer. Okay. Go through it. Be careful while seeing the digits. I thought this is 10 power minus 2, all are 10 power minus 3, but no. This is 10 power minus 2. So this makes the exact correct answer. Moving on to the question number 4. Question given here is, a gas is found to obey P square V is equals to constant. And we know ideal gas is PV is equals to RT. Initial temperature T0 V0 is expanded to final volume to V0. Final temperature is asking you to make a relation between temperature and volume. So what we can say here, V is equals to RT divided by P is equals to, because I want to eliminate the P here, P is equals to RT by V from this equation. Now we substitute this equation in the first one, P plus RT by V. So RT by V whole square times of V is equals to constant. R square T square V square into V is equals to constant. R square is a constant, V gets cancelled. So T square is directly proportional to volume. Okay. So we can say volume, final temperature is, final temperature. So T is directly proportional to root V. So T2 divided by T1 is equals to root of V2 divided by V1. Where T2 is equals to root of V2 is how much? 2V0. V1 is how much? V0. V0 cancel. What is the answer now? Root 2T, where initial temperature is T0. So this is going to become your correct answer. Root 2 T0. Go through it. Ideal gas equation, PV is equals to RT, we have to memorize. PV equal to RT. Sometimes it will mention, sometimes it will not. Eliminating the extra term, that is pressure, by resubstituting in the given equation of P square V. Once P is eliminated, only left out is temperature and volume. Moving on to the next question. Constant in the ideal gas equation is known as, you know ideal gas equation, PV is equals to N into RU into T, where RU is the universal gas constant. Universal gas constant. Value for the universal gas constant, RU is equals to 8.314 joule per mole Kelvin. Joule per mole Kelvin. Okay. So what is the constant which is there in the ideal gas equation? Universal gas constant. Moving on to the next question. Question which appeared in the 2023. Every gas behaves an ideal gas at, this is the condition for Boyle's law for real gas. So that real gases behaves as ideal gas. Okay, what is that condition? At a high temperature and a low pressure. At a high temperature and a low pressure. Now try to study like this. At high temperature, low pressure, all real gas behaves as ideal gas. high temperature, low pressure. High temperature, low pressure. High temperature, low pressure. Option number 3. Go through it. And Boyle's law is valid for ideal gas only. Boyle's law is valid for real gases. What is the condition? High temperature, low pressure. Because real gases will be behaving as ideal gas at high temperature and low pressure. Next one. The Boyle's law is stated by PV equal to constant. Depends on. In ideal gas equation, PV is equals to M into R into T. Where R is what? A constant. Mass is what? A quantity. T is what? A temperature. If I want to write PV is equals to constant, that means I am saying that this C is depending upon mass and temperature. So mass is quantity. So what is the correct answer for this? C depends upon what? Quantity and temperature. Okay. Next question. The equation of state for 5 grams of oxygen, pressure P, temperature T, occupying a volume V, then R will be dash. Equation is asking. You know PV is equals to N into R into T. MRT or NRT. This is universal gas constant. N is mass divided by molecular weight. Mass divided by molecular weight. Two formulas we have for the N. N is number of moles. Number of moles is mass by molecular weight. One more formula we have seen in the starting question, that is number of molecules divided by Avogadro's number. Two formulas we have. Right. So I will be using now this formula. N is equals to mass by molecular weight. What is the mass? 5 grams. What is the molecular weight of oxygen? 32. 5 by 32. So in the place of N, what we can substitute now? 5 by 32. PV is equals to N RT. PV is equals to 5 by 32 RT. This is your answer. PV is equals to 5 by 32 RT. Have to memorize that number of moles is equals to mass divided by molecular weight. Mass by molecular weight. Moving on to the next question. The next question given is the equation of state correspond to 14 gram of nitrogen. Similar question. Asked question is in terms of nitrogen now. PV is equals to nRT. R is the universal gas constant. PV is equals to mass by molecular weight times of RT. PV is equals to mass is given how much? 14 grams. Molecular weight of nitrogen is 28. RT. 14 ones are 14 twos are. So what is the answer? PV is equals to half universal gas constant R and T. PV equal to half into R into T. This is your question. Moving on to the next question. A vessel contains certain quantity of gas. Pressure is 80 centimeter. Pressure is 80 centimeter. If 2 by 5th of the mass gas leaks, if M1 is equals to M, M2 is equals to M minus 2 by 5 times of M, because leaking is there. So 5M minus 2M, 3M. 3M divided by 5, final mass. And final pressure, remaining gas pressure is how much? P2 is equals to 1. P2 is equals to 1. We know PV is equals to MRT. Assuming everything as constant, P is directly proportional to mass. So P2 divided by P1 is equals to M2 divided by M1. P2 is equals to M2 is how much? 3M by 5. M1 is how much? M only into P1. P1 is 80. MM cancel. 3 into 80 divided by 5. 5 ones are 5. Remaining is 3. 5 6 are 30. 16 3s are 48. Okay. So what is the answer going to become now? 48 centimeter of Hg. This appeared question in 2024, shift 2. Very simple questions. Now let's see some most expected question, important questions for the ECET 2025 based on the concept that we have learned. Now the question is given as, okay, P1 V1 M1 T1 P2 V2 M2 T2. Then the equation is asking for. We know that PV is equals to M into R into T, where R is a constant. We can write like this: constant is equals to PV divided by MT. That is P1 V1 by M1 T1 is equals to P2 V2 divided by M2 T2. So this is your equation. P1 V1 by M1 T1 is equals to P2 V2 by M2 T2. Okay. Moving on to the next important question. The relation between the universal gas constant and Avogadro's number. While discussing about the number of moles, number of molecules equation, I told you this: Avogadro's number in terms of Boltzmann constant. Boltzmann constant K is equals to universal gas constant divided by Avogadro's number. K is equals to R by N. Then R is equals to Nk. R is equals to Nk. This is an expected question now in the examination. Okay. Moving on to the next question. How much should be the pressure of gas be increased to decrease the volume by 10%? What's the value for the pressure to be increased when the volume is reduced by 10%? Already we have solved similar question. Try to understand that volume reduces by 10%. V1 is equals to 100, then V2 is equals to 90. Okay. Then asked question is increase in pressure. We know the formula for percentage increase in pressure is equals to P2 by P1 minus 1. P2 minus P1 by P1 into 100. That is equals to P2 by P1 minus 1 into 100. We know that temperature is constant. So P1 V1 is equals to P2 V2. So in the place of P2 by P1, we can write V1 by V2. V1 by V2. So this will become like this: V1 by V2 minus 1 into 100. Substituting it here, V1 is how much? 100. So 100 by 90 minus 1 into 100. It can be written as 100 minus 90 divided by 90 into 100. That is 10 divided by 90 into 100. That is 1 divided by 9 into 100. That is 0.111 into 100. That is 11.1%. Okay, what is the correct answer now? Option number 3. Very simple question, but yet effective for the ECET examination. Next question. The graph between the temperature in degrees Celsius and pressure for perfect gas is. Okay, this is the graph. This is the graph where this is the diagram you will be getting. Okay, that's the values are here. This is the pressure axis, this is the temperature axis. You can see here pressure is not equal to 0 and temperature is becoming what? 0 degrees Celsius. Here final pressure is becoming 0 and the temperature is minus 273.16 degree Celsius. So this is the line which is intercepting at pressure axis, like a positive intercept on the pressure axis, and intercepting the temperature at minus 273. So this is a straight line with positive intercept. This is positive intercept now, and second intercept is where temperature is going to become minus 273. So this is going to become your answer. Similarly, this question can be asked for volume also. Okay, when ideal gas is reducing its temperature, okay, let's say this is volume and it's a temperature. The final volume is going to become what? 0 at a temperature of how much? Minus 273.16 degree Celsius. Here final, this volume is not equal to 0. This is positive intercept on the volume axis. Okay, go through it. Moving on to the next question. The next question and the last final question for this ideal gas important question bits are: volume is given as 100 cc, constant pressure. In the PV by T, if pressure is remaining constant, the formula is V1 by T1 is equals to V2 divided by T2. V1 is given as 1000, T1 is given as 27 plus 273, this is 300 Kelvin. 327, this is 600 Kelvin. 600 Kelvin. Then what it will become now? V2 divided by, this is 300 Kelvin, this is 600 Kelvin. 300 ones are 300 twos are 1000 twos are 2000. So V2 is equals to 2000 cc. V2 is equals to 2000 cc. This is your okay. So that's all about the ideal gas part 1 and part 2. Make sure if you haven't watched the part 1, watch the previous videos of thermodynamic processes part 1, thermodynamic processes part 2. Very effective and important repeatedly asked questions from the chapter, from the topic thermodynamic processes. The second most important is ideal gas. Part 1 and part 2 has been completed with this very video. With regular content we are updating in the SAIMEDHA YouTube channel. So subscribe the channel, press the bell icon, and every day with some motivation, okay, come back, okay, at the evening 7 p.m. take out this channel, take out the video, take out your books, pens, start noting down the questions and keep solving, okay. Definitely this is going to be improvising your physics knowledge, and those who are going to be having some hesitation in the physics, definitely that hesitation is gonna reduced to very maximum extent and you can perform well in the final ECET examination. I wish you all the best with such more content. I'll be coming back tomorrow in the next video. Till then, keep learning with SAIMEDHA.in app.